Welcome to Seed Survivor. My name is James.
And I am Isabella.
Today, you're going to learn about growing healthy plants and the importance of agriculture. What does a seed need to grow? Sun, air, water, healthy soil, and nutrients.
What would happen to a plant if you completely covered it or left it under your bed in the dark? It wouldn't grow. Plants need sunlight and air for the photosynthesis process.
What happens to a plant that is unwatered? It will dry up. What about if the plant is overwatered? It would drown. Like most things, you need the perfect balance of not too much or too little water.
Plants need soil nutrients to grow. Nutrients are plant food. The air and soil already have nutrients, but not always in a form that can be used by plants. Farmers will manage and add nutrients to the soil to provide the exact nutrients needed by crops. Where do these nutrients come from? Nature. Fertilizer, manure, organic sources like decaying plants and animals, and compost. All of these things together create a healthy soil for plants to grow in. We'll come back to nutrients later.
Why is healthy soil important to us? Because we can't live without it. Plants grow in soil, and animals feed on these plants. And we feed on both. Soil supplies and cleans water. We build homes on soil and with the items from soil, like clay blocks, stones, and rocks. Plants growing in soil provide us with oxygen that we breathe. And soil provides shelter for many animals and insects, which in turn keep the soil healthy. As crops grow, what is in the soil to keep it healthy? Soil organisms, like worms or tiny microorganisms we can't see without a microscope. Air, water, organic material, and nutrients. Soil health depends on a balanced relationship between all of these things in the soil. Soil is actually a living ecosystem.
It's also important to understand the type of soil in order to know what will grow the best. Soil is made up of 3 different particles: sand, silt, and clay. These particles are different sizes. Sand is the biggest, followed by silt, and clay is the smallest.
Why does the size of the particles matter? Well, if the soil is largely sand, the biggest particle, there will be more space between each particle, so water will flow through really fast and could leave your plant thirsty.
But if the soil is mostly clay, the particles are really close together, so when water flows through it, it stays longer. This can deprive a plant's roots of air and even drown it.
Healthy soil, or the ideal crop soil, we call loam, which is generally dark brown, earthy smelling with lots of organic matter, and mix of particle sizes.
Now that we are experts on what a seed needs to grow, sun, air, water, healthy soil, and nutrients, it's time to plant sunflower seeds. Here is what you need.
Now, take your cup filled with nutrient-rich soil. Take 2 fingers, make 2 holes. Don't go down too deep. You have to leave room for the roots once the seed starts to grow. Place 1 seed in each hole. Cover the seeds up with more soil. If you're planning to transport the cup, use the lid to keep the contents inside the cup.
Once at home, remove the lid. Keep the soil moist by adding about 1 tablespoon of water each morning. Depending on how moist your soil is to begin with, you may need to add more water the first time. Always check the soil before adding water to see if it needs it. Your soil should feel like a damp sponge.
Put the cup in a sunny window. The Gigantea seeds will sprout in about 3 days. And after 2 to 3 weeks, or once the plant is roughly the size of your hand, transplant the plant into the garden or large pot indoors with access to sun. If properly cared for, Gigantea sunflowers will grow up to 7 feet tall.
Now let's talk nutrients. A plant requires 17 nutrients, but the main nutrients all plants need for healthy growth are nitrogen, phosphorus, and potassium. We can grow more plants on the same piece of land if we use the right nutrients, at the right time of year, in the right amount. not too much and not too little, and in the right place near the seed, referred to as the 4 R's.
When fertilizers are used properly, they provide the exact nutrients needed by soils and plants. This is good news for us too, as it means that the plants we are eating are healthy and nutrient-rich. Applying fertilizer based on science also reduces the risk of losses to the environment.
Fertilizer helps grow around 50%, half of the world's food supply. Without it, we couldn't feed everyone.
The first element we will go over is nitrogen, or N. Each nutrient we discuss will have a fun action to go along with it to help you remember what it does for the plant. For nitrogen, show me your muscles. That's what nitrogen does for plants. It helps plants stay green, healthy, and strong. Nitrogen helps the plants we eat become good for us by adding proteins we need to grow and be strong. Where do you think nitrogen comes from? Here's a clue. Take a deep breath of fresh air. You just took a deep breath of fresh nitrogen. That's right, nitrogen, the nutrient that makes up 16% of the protein in our bodies, comes from the air. 78% of the air we breathe is nitrogen.
Now you may wonder, if so much nitrogen is in the air, why do we need to produce nitrogen fertilizers? Well, the funny thing about nitrogen is that while it surrounds everything, it's not in a form that most crops can use. Only legumes, like soybeans, peas, and alfalfa, can draw nitrogen directly from the air. They work with bacteria living in the soil to transform nitrogen in the air to a form that can be used by these plants. We call this nitrogen fixing. Other crops need to have nitrogen delivered in a digestible form. That's where fertilizers come in. Fertilizer companies take nitrogen from the air and mix it with natural gas through a unique and complex process to form nitrogen fertilizers.
Phosphorus is up next. Okay everyone, let's pretend to catch the sun's energy. Phosphorus helps the plant to use the sun's energy to make food through photosynthesis. We get both nutrients and energy from the foods we eat, but it doesn't exactly work that way with plants. They require both nutrients from the soil and energy from the sun. Plants also need phosphorus to grow healthy root systems. Where do you think phosphorus comes from? Here's a clue. This comes directly from nature too.
Phosphate is nothing more than fossilized sea creatures mined from rock deposits in the earth. We could call it fish fossils. When the ocean that once covered much of North America receded, it left behind the remains of sea life. Most of this material reacted with bacteria to form phosphate particles, but some of it was too hard to break down. What remains are fossils. North Carolina, Florida, Idaho, and Tennessee are the most common North American places that have phosphate rock. Can you guess what sea creature made this fossil, found in one of Nutrien's phosphate mines? The fossil is a jaw fossil from an extinct shark that lived about 250 to 270 million years ago, called Helicoprion.
No one knows for sure, but artists have drawn what they think it would look like. Do you know what one of the most common byproducts is of the phosphate mining process? Shark teeth.
Potassium is the last main element we will talk about. Fertilizer potassium is sometimes known as potash. For potassium, let's become our best boxers and punch in the air in front of us.
Known by the letter K, potassium is often called the protector. Potassium protects our plants against diseases and helps them stay healthy when it's cold or dry. It also helps plants move nutrients and water in the stem, so the plant doesn't wilt. Where do you think potassium comes from?
Potassium, or potash, is mined from evaporated oceans nearly 3,000 feet below the surface of the Earth. You heard me, 3,000 feet deep. That's nearly 1 kilometer, or over half a mile. Do you know where the most significant potash deposits in the world are found? Saskatchewan, Canada.
So instead of making potash, it's pulled out of the ground, washed, and resized into granules that farmers spread on their fields.
Agriculture has a big job in feeding over 7 billion people. By 2050, the population is expected to reach nearly 10 billion, even though the amount of land on Earth stays the same. So as the world's population gets larger, it becomes even more important that we make wise decisions about how it's used.
Let's pretend that this apple represents the Earth. How much of the Earth's surface do you think is devoted to growing the food we eat every day? If you look at a globe, what is the main color you see? Blue. About 75% of our world is covered in water. The remaining 25% represents land. What do you see in the picture? Land such as deserts, polar regions, and mountains aren't good places for people to live or grow food. This section has to be removed because although people live here, the land is taken up by other things like parks, schools, roads, and cities. We can't grow a very good crop in the downtown of a city. The small section remaining represents 8% of the Earth's surface that is used for agriculture. Most of this piece represents agricultural land used for livestock. About 6% of the Earth's land is used for grazing and to grow crops to feed livestock. The rest is the soil on which we have to grow food that humans eat. Approximately 2% of the Earth's surface.
But the great news is that farmers are stewards of the land. For example, in India, on land that is wet, they grow rice that thrives in that climate. And on land that is dry, they grow cotton. We should thank the people that work in agriculture for the food in our bellies and the clothes that we wear.
And did you know that around the world, approximately 1/3 of our food is wasted? In developing countries, such as countries in Africa, food is lost to unreliable transportation and storage. In developed countries like Canada and the USA, food is overconsumed and thrown out because we take too much.
What else is wasted when we throw out food? The money to buy it, fuel, labor, time, and energy to produce it, water and soil nutrients to grow it, nutrients someone else could have eaten. Millions of people would have the food they need to thrive if we protected the food we grew and shared what we didn't need.
We are going to leave you with something to think about.
Farmers use science, technology, and best management practices to feed our growing population in a way that protects the environment.
But it is up to all of us to do our part to care for the land, air, and water.
How do you care for the environment? Or what could you do to reduce your environmental footprint?
Here are some examples. You could recycle, compost, pick up litter, and don't waste food or water.
Thank you for joining us today.
And have fun watching your sunflowers grow.